Hello everybody, welcome into another lesson. So today we're going to do a lesson on perpendicular lines. This might seem like a bit of a review at first, but perpendicular lines, they are two lines that intersect in such a way that they form right angles. And actually when two lines intersect, they form four right angles. Now, if lines intersect and if you know even one of the angles is a 90-degree angle, a right angle, it's enough to conclude that both lines are perpendicular by definition of perpendicular lines. And the way we would write this to abbreviate it is you could say line JK. So we'll say line JK is perpendicular. That's the symbol for perpendicular to line MN. So we can say that line JK is perpendicular to line MN. So that's how you would write it in a proof. Okay. Now there are three theorems today about perpendicular lines. We are going to do two proofs, and then we're going to do a few algebra problems related to the perpendicular lines. So we have our very first theorem of the day. The theorem states that if two lines are perpendicular, then they form congruent adjacent angles. So the theorem is if two lines are perpendicular, then they form congruent adjacent angles. So again, let me draw perpendicular lines here. It doesn't gotta be anything fancy. I'll only deal with two angles this time. I think that should be sufficient. We'll call this line AB. We'll call this line going up and down CD. So the line going left to right is AB, the line going up to down is CD. So if AB is perpendicular to CD, that tells us that angle 1 would be congruent to angle 2, and they would be adjacent angles. Well, that makes sense because line AB, the measure of that angle would be 180. Perpendicular would split it up. You would have angle 1 being 90, angle 2 would be 90. Well, 90 equals 90, and they're right next to each other, so they're adjacent angles. So that makes sense. And then the next theorem is the converse of that. So if two lines form congruent adjacent angles, then they are perpendicular. So if two lines form congruent adjacent angles, then they are perpendicular. So the converse of the first theorem is what this is, and this is also true. Well, if we know angle 1's congruent to angle 2, they're adjacent angles, right? And the only way supplementary angles that form a whole line are congruent is if they both equal 90, which would have to mean that the lines are perpendicular. So that theorem also makes an incredibly good amount of sense. And then I have one more theorem. It's going to be a different diagram for this one though. The third theorem is if the exterior sides of two angles are perpendicular, then the angles are, I'm going to abbreviate this word, complementary. I'll just abbreviate it comp. So the last theorem is if the exterior sides of two angles are perpendicular, then the angles are complementary. So let's draw a nice diagram of this. We'll just draw a simple 90-degree angle here. This will be AB and then C here. Okay. And then, heck, we'll draw a ray. We'll put point D on here. All right. So, in other words, this is saying that if AB here, if line AB is perpendicular to line BC, because let's take angle ABD. Well, line AB is the exterior side of angle ABD, right? Line BC is the exterior side of angle DBC. That's exterior because they're on the outside. Ray BD would be right in the middle. It's definitely not an exterior side. It's an interior side. So, based on this, line AB is perpendicular to line BC. Then we can say that angle ABD is complementary to angle DBC. So now we can say that angle ABD is complementary to angle DBC. That's all that theorem's saying. And that also makes sense, right? If these two lines are perpendicular, they form a 90-degree angle. And the two angles inside here, well, yeah, they would have to add up to 90 by the angle addition postulate and by the definition of complementary angles, right? So, yeah, that theorem's based off of those two. So, pretty simple theorems about perpendicular lines. Okay. Let's do our couple proofs, and we have a few algebra problems. So, let's do this here. I'm going to draw me a nice diagram here. Doesn't got to be fancy. Again, I'm not Bob Ross, so I'm not the best at drawing, but let's see, this will be line L, this will be line N, this will be angle 1, this will be angle 2. Okay, so in our diagram here we have lines L and N intersecting with angles 1 and 2. Now, based on this diagram, they give us, we are given that angle 1 is congruent to angle 2. Alright, so now they tell us angle 1 is congruent to angle 2. We have to prove that line L is perpendicular to line N. So we are given angle 1 is congruent to angle 2. We got to prove that line L is perpendicular to line N. So let's go ahead and set up our proof. Alright, so let's form our column here. Columns, I should say, plural. Let's see, put our statements here on the left. We'll do our reasons on the right. Okay, so the first thing, we'll start with the given information, that angle 1 is congruent to angle 2. Right? Angle 1 congruent to angle 2, the reason for that is it was given to us. So that one was easy. Now we need to add up the measure of angle 1 plus the measure of angle 2. We'll get 180 degrees. So let's see. The measure of angle 1 plus the measure of angle 2 is going to equal 180 degrees. That would be given by the definition of supplementary angles. So, by the definition of supplementary angles, the measure of angle 1 plus the measure of angle 2 equals 180 degrees, right? Now, here's where it starts to turn interesting. We know angle 1 is congruent to angle 2, which means in this equation right here, we can substitute either one for either one in the equation. I'm going to go with angle 1 for angle 2. So in this, I'm going to say the measure of angle 1 plus the measure of angle 1 equals 180 degrees. We could have done the other angle. It really wouldn't have mattered. And of course, the reason for this is the substitution property. All right, so we got that. Now, the fourth thing is, since we have two measure of angle 1s, we can treat them like variables. You'll have twice the measure of angle 1 is equal to 180 degrees. This would be by the addition property. So by the addition property, twice the measure of angle 1 equals 180 degrees. Now let's see the fifth reason, the fifth statement. We divide both sides by 2, you'll get the measure of angle 1 equals 90 degrees. This would of course be by the division property. So by the division property, we can now prove that the measure of angle 1 equals 90 degrees. Which, our final step, we can now prove that line L is perpendicular to line N by the definition of perpendicular lines. Definition of perpendicular lines. Okay, so we started here in our proof. You stated the given information. Angle 1 is congruent to angle 2. That was given to us. The next thing then we wanted to do was add the measure of angle 1 plus the measure of angle 2, set it equal to 180 by the definition of supplementary angles. It's very clear if you add these two angles, even though we don't know yet that they're perpendicular lines or 90 degrees, even though we don't know that yet, that whatever the values of these two are, if you add them together, you'll get 180 degrees. That much should be clear to start. Now the third step, angle 1 is congruent to angle 2. So in the equation, I was able to substitute angle 1 in for angle 2. And therefore, by the substitution property, I can do that. So this means twice the measure of angle 1 equals 180 by the addition property, which means the measure of angle 1 equals 90 by the division property. And so since we know even one of the right angles is a right angle, that means line L is perpendicular to line N by the definition of perpendicular lines. So that's the proof of the converse of the theorem that we gave. That's the proof of if two lines form congruent adjacent angles, then they are perpendicular. We're not going to prove the original because it's pretty similar to prove the original. We're just going to count them both as proved. But the third one we did, we're going to prove real quick here. Do one more proof, and then we have a few algebra geometry problems. So let's see here, okay? Draw me another diagram. This will be point A. This will be point O. This will be point C. And then, okay. We have ray OB here. Alright, so in this diagram we have two angles formed by rays AO and OC with a ray in the middle stemming from point O. We have ray OB. Now, what we are given here, we have been given that ray OA is perpendicular to ray OC. So we're given that ray OA is perpendicular to ray OC. Alright, what we have to prove, what we're about to prove here is that angle AOB and angle BOC are complementary angles. So what we're going to prove here is that angle AOB and angle BOC are complementary angles. This is going to be the proof of the theorem that states if the exterior sides of two adjacent acute angles are perpendicular, then the angles are complementary. So let's go ahead, let's set this bad boy up. Alright, so let's see, statements to the left, reasons to the right. Okay, so I'll start with the given information again for my first statement. That's going to be that ray OA is perpendicular to ray OC. We got that. The reason is the given information. So that was given to us. Okay. What that means then, we know, based on the fact that these two rays are perpendicular, is that the measure of angle AOC equals 90. So if these two rays are perpendicular, then the measure of angle AOC equals 90 by the definition of perpendicular lines. So that would be statement number 2 and reason number 2, measure of angle AOC equals 90 by the definition of perpendicular lines. Okay. Now, next step here, we have the measure of angle AOC. That means that the measure of angle AOB plus the measure of angle BOC equals the measure of angle AOC. So the measure of angle AOB plus the measure of angle BOC equals the measure of angle AOC. This is simply by the angle addition postulate that we've learned already. By the angle addition postulate, the measure of angle AOB plus the measure of angle BOC equals the measure of angle AOC. Now, we're actually almost done. Step 4 is, right, okay, we know the measure of angle AOC equals 90, don't we? That means since we have this equation here, we can substitute the whole first part of the equation in for the measure of angle AOC. So now we can state that the measure of angle AOB plus the measure of angle BOC is equal to 90, simply by the substitution property. We could put that in for reason 4 by the substitution property. Alright, so now that we've gone from there, there is one final statement. If these two angles add up to 90 degrees, then that means they're complementary angles. So we can now say that angle AOB is complementary to angle BOC simply by the definition of complementary angles. That's an easy enough reason. So by the definition of complementary angles, we can say that angle AOB is complementary to angle BOC. Okay, so let's go over this proof again here. We were given that ray OA is perpendicular to ray OC. That was the given statement. Now, the next thing we did, that means since ray OA is perpendicular to ray OC, that means the measure of angle AOC would have to equal 90. That's simply by the definition of perpendicular lines. Well, we know now for statement 3, the measure of angle AOB plus the measure of angle BOC, if you add those two together, you'll get the measure of angle AOC. That was by the angle addition postulate. So, since we know the measure of angle AOC equals 90 for statement 4, we could substitute in that the measure of angle AOB plus the measure of angle BOC equals 90. That was simply by the substitution property. And then, for the final step, well, if the sum of those two angles equal 90, that means they're complementary angles. So we were able to prove the angles complementary simply by the definition of complementary angles. So there's the proof of that theorem there. Alright, time for a little bit of fun now. Time for a little bit of algebra with geometry. Personally, I like geometry a lot, I really do, but I always was more of an algebra fan. And based on what I'm seeing lately, I think a lot of you guys are too, but someone out there needs geometry help, so I'm going to teach it, because... Okay. We have here, let's draw another diagram. It's not a proof this time. So there's good news there. I don't have a proof here. Okay, I have line AB. Wait, that's not correct. It should be point C, not... Excuse me a minute. Alright, that's B here. So far, I have line AB with ray BE perpendicular to line AC. Let's see, from here, I got ray BF. That's ray BF there. And then I have one more. Alright, this here is going to be ray BD. Alright, so we have a nice setup here. We have a nice diagram here with line AC, and then we have three rays stemming from point B. Rays BD, rays BE, rays BF. We are given that ray BE, that looks awful the way I wrote it. Excuse me. We are given that ray BE is perpendicular to line AC. So we are told that ray BE is perpendicular to line AC. We are also given that, if it's what I think it is, yep, ray BD is perpendicular to ray BF. Alright, so we've been given here that ray BE is perpendicular to line AC. Ray BD is also perpendicular to ray BF. So we can start with that. Our next task is to find the value of x. So we have some algebra problems again. Find the value of x. This is where algebra and geometry collide. First problem, let's see. ABD is equal to 2x minus 15. So this is 2x minus 15 degrees. And DBE equals x degrees. We want to find the value of x. Right? Well, here's something. Since we know ray BE is perpendicular to line AC, that means that angle ABE, or EBA, however you want to write it, that means that that's a 90 degree angle since they're perpendicular lines. So now what you're going to want to do is take that 2x minus 15 plus your x, and you'll set that equal to 90, right? Since these two together would form a 90 degree angle, which now would give you 3x minus 15 equals 90, which means 3x equals 105, which means x would have to equal 35. So the answer for this one is that x would equal 35 degrees. All right. We got another problem here. We only have a few problems. There aren't that many. I know, much to everyone's relief, right? But these are important problems. It's important to see how algebra and geometry relate. They do very much so. All right, angle DBE is equal to 3x. Angle EBF is equal to 4x minus 1. All right, so we're given now that angle DBE is equal to 3x, and angle EBF is equal to 4x minus 1. Well, we are given that ray BD is perpendicular to ray BF, which means that the total angle DBF would equal 90 degrees. So again, we're just going to add these two together. You'll take your 3x plus 4x minus 1, that would equal 90, which means you would get 7x minus 1 equal 90. So 7x equals 91. All right, and then let's see. That would have to mean that x would equal 13. So the value of x for this particular problem would be 13. All right. Yeah, these really aren't too bad. These problems really aren't that bad at all. I have here actually two more. That's it. All right, angle ABD is equal to 3x minus 12. Angle DBE is equal to 2x plus 2. 2x plus 2 for angle DBE. Angle EBF is equal to 2x plus 8. All right, so we have angle ABD is equal to 3x minus 12. Angle DBE is equal to 2x plus 2. Angle EBF equals 2x plus 8. They don't give us the value of angle FBC. That's okay. This is a problem where they're trying to trick you deliberately. It looks like we need to add the sum of three angles. Well, based on the given information, what do we know? What do we know? We know for a fact that ray BE is perpendicular to line AC. We also know that BD is perpendicular to BF. There are two ways you can do this problem. You can add the sum of 3x minus 12 plus 2x plus 2, since angle ABE would be since these ray and line are perpendicular, angle ABE would be a 90-degree angle. And then since BD is perpendicular to BF, angle DBF would also be a 90-degree angle. I'm going to do it both ways just to illustrate. That would mean that for the first one, if we add up 3x minus 12 plus 2x plus 2 to be 90, which we're going to do, that means that we need to throw out the 2x plus 8. We're not even going to consider 2x plus 8 because right here with these two we have 90 degrees. So there's no need to include 2x plus 8 in this one. Yeah, let me move this over a little bit because I'm going to show both ways. Alright, so we have 3x minus 12 plus 2x plus 2 is equal to 90. Which would simplify into 5x minus 10 would equal 90, which means 5x equals 100, which would mean that x equals 20. So that's one way to ascertain the value of x. We use the fact that line ABC is perpendicular to ray BE, meaning that angles ABD and angles DBE together would add up to 90. Now, for the second way to do it, you can pick your poison. We know ray BD is perpendicular to ray BF, so that means angle DBE, which would be 2x plus 2, plus angle EBF, which would be plus 2x plus 8, that equals 90. Since those are perpendicular, which if you take this route, that means you're going to throw out the 3x minus 12. You don't need that. So as I said, they will try to trick you. You got to be very careful. So simplify this here, you would have 4x plus 10 is equal to 90, which would have to mean 4x equals 80, which also means that x equals 20. So either way, you arrive at x equals 20. Just pick your poison. So be on the lookout for problems like this. They will try to trick you from time to time. Okay, then I have one last problem here. One last problem and then we're done. Although it might be kind of a long one because there's actually going to be 3 ways to solve the next problem. which the third way I'm definitely not going to recommend, but I'm going to show it to you anyway. Alright. Angle ABD is 6x, so that's 6x. Angle DBE is equal to 3x plus 9. So angle DBE is equal to 3x plus 9. Angle EBF is equal to 4x plus 18. And then angle FBC is equal to 4x. Alright, so we have some form of measurement for all four angles now. Again, you could argue that they're trying to trick you a bit, when really they're not even trying to trick you, they're trying to give you options. That's really what they're trying to do. Actually, if you think about it, there's 4 ways we can solve it. I'll show 4 ways. So let's start with the fact that ray BE is perpendicular to line AC, right? That means that angle ABE would have to be a 90-degree angle since you got the perpendicular thing going. So that means angles ABD plus angles DBE, if you add them together, would give you 90. So we'll take 6x plus 3x plus 9, set that equal to 90, which means you would get 9x plus 9 equals 90, which means 9x would equal 81, which simply means that x would equal 9. For all 4 of the ways I'm going to show you, we should arrive at x equals 9. It should not make a difference. So adding these 2 angles together, I get the fact that x equals 9. Now, way number 2, again, we'll use the same ones here. Ray BE is perpendicular to ray AC. Ray BE is perpendicular to line AC, which also means that angle EBC would have to be a 90-degree angle, wouldn't it? So you can take that 4x plus 18 plus yet another 4x, set that equal to 90, which means then you would end up getting 8x plus 18 is equal to 90, which means then you would get 8x equals 72, which then means that x equals 9. So we've obtained 9 with 2 out of the 4 methods so far. The other 2 should also give us 9. Alright. Now we also have here that ray BD is perpendicular to ray BF, which means angle DBF should also be a 90-degree angle. These last 2 ones I don't recommend, but if you want to do it, you like the challenge, you can do it. You could take angle DBE plus angle EBF, which would be 3x plus 9 plus 4x plus 18, and set those equal to 90, which should give you 7x plus 27 is equal to 90, which would then have to mean that 7x equals 63, which therefore also gives you that x equals 9. So x equals 9 by that way too. And the last one I truly don't recommend, but it would still be correct. We know all 4 of these angles together make up the whole line, right? They all together add up to 180 degrees, so let's go ahead and do that. That means 6x plus 3x plus 9 plus 4x plus 18 plus 4x, they all together add up to 180. So let's simplify this. 6x plus 3x is 9x, plus 4x is 13x, plus 4x is 17x. So you'll get 17x. See, 9 plus 18 is 27. So you get 17x plus 27 would have to equal 180. which would then give you that 17x. Let's see, that would equal 180 minus 27. That would be 153. Which, what do you know? X equals 9. X also equals 9 by doing that. So, pick your poison. You can do any of the 4 ways we've done it. If I were you, I would pick one of these 2 angles here, angle ABE or EBC, add those up to 90, because you're working with smaller numbers. Who wants to work with big numbers like we just did? So that's really it for this lesson. Next lesson we're going to have a couple theorems about complementary and supplementary angles. So I hope everyone has a good night. Take care.